This comes from an MIT project. It's always funny when my students come to me like, whoa, they teach stuff you're teaching at MIT. I'm like, yeah, but not as good. So, because MIT guys are all researchers, right? They spend a lot of time researching. And ladies, too. MIT ladies, guys and ladies. What you're about to see is a blend of how to interpret matrix addition via a computational photography problem. You ever seen those nice like CSI Miami or whatever? And they're always like racial profiling people, and they're like, oh, someone's a terrorist. And then they're like, oh, let's take their picture and run it through the database. And then you see like stuff on the screen, and then like, there's a match, and then they go get them. That algorithm that there are many different algorithms for facial recognition technology. Not all of them are linear algorithms, but there are some major algorithms in facial recognition technology that depend on linear algebra. That's a dramatic representation of a paycheck for an applied mathematician. Because the person that wrote that computer program was doing some calculations. And what I want to show you here is this is a blend of these two people. Right? So these people in the 1990s, this is online, so I felt good about using this. It's open access, right? These people were in some sort of a class at MIT, person on the left, person on the right, and then you could ask, well, what would it look like if you blended the two people? So you take 50% of the person on the right and 50% of the person on the left, and you get that person. This is a matrix. The thing that on the left-hand side, literally, you remember what we said about that matrix? It's a square matrix. Maybe you say it's, what is that? 2,147 bits, pixels by 1,734 pixels. If it's black, if each entry is black, can you guess what we say? 0, 0, 0, 0, 0, however many bits is used to encode it. And then you have shades of non-black, right? Yeah, and so now you get a set of a bunch of pixels on the left-hand side. You get a set of a bunch of pixels on the right-hand side. Do you know how to add two numbers in a computer? Yeah, use binary addition, right? So now you just scale the one on the left by 50%, scale the one on the right by 50%, add them together, and then you get this like hybrid person that kind of has glasses, kind of has weird-looking hair. Yeah, right? And then you could be like, well, what if the one on the right was really dominant? So then you drop the scalar down to like 20% on the left, 80% on the right, and you could actually do a linear combination between the two of them, right? You could like go from 0% on the left, 100% on the right, and then slowly like you could even like code it up on one of those joysticks, whereas the joystick is down, it's 0, and then you go up and it goes to 100%, and it's a blend in between. And then if you just kept doing that for years and years and years, eventually you get a job at Hollywood making graphics for Marvel, right? I mean, that's not really linear algebra, but it's computer graphics, right?